Alright guys, so what we're going to be doing right now is showing you guys how to add and subtract vectors. We kind of talked about it yesterday when we had vectors. I'm going to make sure I get a nice looking vector right here. So if I call that vector, I don't know, vector A, and I wanted to add vector B, like that, how do I actually add these vectors together? You guys remember? You got to put them together, what to what? Tip to tail, tip to tail. So if we wanted to add these vectors together, I'd have to grab this guy and make sure it's going in the exact same direction with the exact same length. That's not too bad, okay? So this would be vector A plus vector B, graphically, okay? Like if we were gonna be using some type of art or graphically. Now this one, all we gotta do is just look at the X component and look at the Y component and just add them together. So yes, it's this simple. This is one component. This is the other component. If we added them together, what's that got to be? Close. It's -1. If we add these together, what would those added together have to be? -18. When you're adding and subtracting vectors, you got to have their components and either add their components or subtract their components. So we're just going to do a couple of problems, and that should be enough to help you guys understand. Now, this is not a graphical representation. It's just algebraically, just add them together. So we have -1 and -18. Okay? Like I said, we're only going to do 2. So check this out. Now we're not adding them. What are we doing? Subtract. This is where students will mess up. We have to take, now it doesn't, remember, order matters. It says W, vector W minus vector U. So I have to take vector W, which is -12 and -4, and I have to take away vector U. And vector U is -5 and a 3. So please, the one thing I'm going to talk about is make sure you know the order. Order matters, not when you're adding, but when you are subtracting. So we have to literally take the -12, take away a -5, which becomes -12 plus 5, which is -7. What's the other one? -4 minus how many more? Minus 3 more. I'll do a better 3. And that gets me another -7. So luckily for me, I get to put -7 and -7. But you got to make sure things are in order. So I'm going to highlight once again what I just did. I took the -12, and what did I take away? I took away the -5, and that's why it became a -12 plus 5. Okay? And then the next thing I did was I took a -4, which is right there, and I took away a 3. And order matters when you're subtracting. So -7 should be my answer. That's not the magnitude, that's just the components that could help you find the magnitude. Remember, it's got an X component and a Y component. -7, -7. All right. Adding, it doesn't matter, right? Adding doesn't matter, subtraction does. So right now, we're going to go to graphically now. Okay? So I don't know if you guys can see this. I wish I could zoom in just a little bit more. But right now, does everybody see vector A going in this direction? Okay. Now, if I add B to that, B's right here, but I'm adding what? B to A. So what would that look like if I added B to A? That goes over 2 and up 4. So I'm going to put over 2, up 4. So I'm going to go over 2 and up 4. I'm just kind of drawing it right here. There's vector B. So there's A, there's B added together. Does everybody understand what this means right here from here all the way there? That means vector A plus vector B. So I'm feeling pretty good about answer choice A. Oh, hold on. Oh, it says choose one answer. So which of the following describes a valid way of obtaining it? Interesting. A does, but check out this one. I know, but look at the magnitude. Would you guys agree that the opposite of vector A would be going down to and over 4? That's negative vector A, right? So that's negative vector A right there. What about negative vector B? That would go down 4 over 2. Oh. Would these actually end up matching? They would. So you got to be careful. This is where you guys need to understand. These vectors right here, remember, magnitude, what is not, magnitude doesn't care if there's no negative magnitude. All right, there are negative components, but there's never a negative magnitude. So I don't think it's just A. I don't think it's just B. I think it's both. Oh, I messed up. It's just A? Well, no, but vector A and V are equal. Hmm. Well, I was wrong. Oh well. Well, I think these this would still they would still be. It's going in a different direction though. It is going in a different direction. Okay, it's going at same magnitude, different direction, so they're not equal. That's okay. I got it. Okay. All right. So right now we have which vector equation matches the vector operation shown in the diagram below. All right. So let's look at tip to tail. All right. We've got vector vector V. Okay. We've got vector U, and we've got vector W. All right. So when you guys are doing these, what you're going to do is do them graphically and see which one actually works with the diagram. So vector V goes down like this. Vector U goes down, I'm going to move it over here, goes down like this. And vector W goes across like this. So what we're gonna do is we're gonna match up these. We're just gonna set these up. Okay. So right now, U plus V. What is U? U goes which direction? I better change colors. Yeah, it goes down to the left. Okay, down to the left. What does V do? It goes down which direction? Down to the right. And vector W goes right there. So I'm going to say answer choice A does not match up. Okay? Let's look at V. V goes down to the right. W goes straight left. Is that going to equal U? Is that U right there? No. Okay. How about this? W. W goes straight to the right. U goes what direction? Right? Down to the left. All right. Is that going to be equal to V, which goes which direction? Right there. So I'm going to choose answer choice C. So I take all of my graphical representations, I put them together and figure out which one is going to work. So I'm going to choose answer choice C. And then I'm going to do it again. I'm not going to get tricked this time. All right. All right, so here we go. So if you're wondering how I'm going to do these, I'll do it one more time. I'm going to separate vector u, vector w, and vector v. So u is going to go down and to the right. No, actually it's going up and to the left. So u goes up and to the left. W goes down and to the right. And v goes down and to the left. So once I get my three little vectors and I draw them out, then I'm going to put them together. So let's do the first one. U minus v. So let's take a look at u. U goes what? Right there. Now what does a minus v do? If a positive v goes down and to the left, what would be a negative v? Up and to the what? Up and to the right. And is that going to be equal to, is this equal to w? No, so I'm going to say that's not it. Okay. All right. U minus v. Well, once again, we have what? U minus v. So there's u. Okay. Minus v goes, that goes down to the left. It still has to go up and to the right. What's a negative w look like? This is a positive w. This is going to be a negative w. So negative w would look that direction. This does not look like a negative w. Let's try the last one. Man, I hope it's right. V goes what? Down into the right. U goes what direction? Up into the left. Which looks kind of like that. Okay. And what does a negative W look like? If this is a positive W, what's a negative W? That's a negative W. Hey, would that work? Yeah, so that's why I'm going to choose answer choice C. Okay, so all we're going to do right now is we're going to look at this diagram and we're going to take these and put these together. We're going to take A, which looks like this, taking A, which goes down like that. We're going to add B. And adding B does this. Okay, and so what is A plus B? A plus B goes right there. There's your A plus B. I'm just doing, if I say A, because if you do, why do we attach it this way? We're doing tip to tail because we're starting with A and then we're adding B to it. Starting with A, then we're adding B to it. Man, I'm gonna say it doesn't look like any one of them. So I'm gonna see step by step just to see, because that was like, that's not the way I was. I wish they would have done a diagram. But what was my diagram? This right here. So I'm taking A. There's vector A. What am I adding to it? I'm adding vector B, and that gives me vector A plus vector B. All right, there we go. I'm dadgum. I'm going to get 100, just so you know. I'm going to get 100. So we have vector A. And what does vector A look like? It just goes up and to the right. So I'm just going to draw up and to the right. Give myself a little bit of space. Vector B. goes down and to the right like this. Oh, negative C looks like this. So if negative C does this, what would positive C look like? Negative C goes like that, then what positive C would go what? Down like that. So I'm just going to go positive C looks like this. Negative C looks like negative C is going up, positive C is going down. So now all I'm going to do is start drawing them out. What does B look like? Down and to the right. What does A look like? Up and to the right. And what does negative C look like? Straight what? Straight up. Is this right here, is that straight up? No. So I'm not going to choose that. B. Down and to the right. Negative C. Negative C goes straight up. Okay. Hey, is that equal to A? Do those all line up? That looks pretty good. So right now I'm looking at B, thinking B is probably the answer. I'll do one more though. A, and then B, which goes like that. Is that equal to C, which goes down? No. So I'm going to choose answer choice B. I mean, you guys can try to do it in your head. That's fine. I just personally, I like drawing things out to see if they work or if they don't work. So I'm just going to write down vector A. This is the last one. We're going to get it right and call it a day. So vector A goes all the way up and to the right. Vector B goes straight across and to the left. Okay. And vector C goes down and to the left. So there's my vector C. All right, so now we're just going to, those are my three components. I'm just going to take them and add them together. A plus B. Let's take A plus B is A plus B equal negative C. Well, if positive C does this, negative C would do this. So that's looking pretty good right there so far. Let's check the other one just to make sure. B minus C. So minus C, if C goes down, minus C would go up. Is that equal to A, which goes down? Let's try that again. If B goes to the left and negative C, if that's positive C, which goes down, negative C would go up. Is that going to equal positive A, which is going up right here? That it's not the same. It's not the same shape. So we have A minus C equals B. A minus C A minus C goes back down like that, and that is not equal to, that's not equal to B. So we're going to go with A plus B equals negative C, because A plus B equals a positive C, but it would also equal a negative C. So when you guys are doing this, what you're going to have to do is you're going to have to map it out. You're going to have to use these diagrams to figure out if it actually works or if it doesn't work. Okay? Hey, and if you get it wrong, it's okay. Just learn from it, just like I did. And what did I learn? In case you're like, what did you learn? All right? One thing we need to understand, the one that I messed up on, okay? Understand that these vectors had the same magnitude, but they had different directions. They have to have the same, in order for them to be perfect, they have to have the same magnitude and direction for them to be equal. Okay? So these did have the same magnitude, but they had different directions. And that's why I messed up on that one. Okay?